Okay, so what I'm going to share is one of the mumbo jumbo documents from the Hawk. Okay, could you all see that? Oop. Screen sharing has stopped as the shared window is closed.
So the document that she's about to share is the same 140 something page document I told you all about a couple weeks ago. Just reinforcing again, pretty much all the information is going to be in that packet. At least one look over and you're probably going to be fine. You don't need to memorize it, but base familiarity would probably be a good idea.
Okay, let's try this again. Can you see that?
Yeah, we can see it.
Okay. All right, so yeah, this is 152 pages. It's really long. Why is it not? There we go. Okay. So some of these highlighted things were actually already pre-highlighted on this. So like if you go to the document from Hawk, some of these highlights are from somebody else. Some of them are mine as I was studying for it. So it's kind of, I guess what I'm saying is the things that you see highlighted are not necessarily the things that I think you guys should focus on the most. They're just a variety of highlights in this document. But I did go through it the other day and just kind of make some marks on things that I think are important. So, or at least I thought I did. Sorry. One more second. I'm just trying to find the version that has my markups.
Rachel, quick question. Sorry, this might be annoying, but I downloaded everything from Hawk last week on Moodle. But do you think I need to go back to the portal and there might be other themes there, or do you think it's probably not updated since last week?
Oh, since last week, I don't think anybody has changed it in the last few weeks.
Okay, cool.
Okay, I found the right one. Okay. Yeah, because I went through and made these little red X's on things I think are important, and then I didn't see the red X's, so here's the right one. Okay. So for the research design stuff, no basic definitions, no things like what is an operational definition, right? We need an operational definition to be able to measure something because we need to know very precisely, right? What our variable of interest is and how we could measure that. Some of these concepts you probably also learned in your class with Dr. Sweeten. You had Dr. Sweeten this year, right? Okay. And I only see 3 of you on this, so if you have questions, just talk because I can't see all you guys. Know the difference between a qualitative and quantitative design, what the difference is, just conceptual understandings of it, nothing so in depth as far as I recall. Know the different kinds of experimental designs. So some of this is from Dr. Dallenberg, right? The different kinds of Anovas, what they mean conceptually, what is the difference between a within group and between group and repeated measures. Remember that with true experimental designs, you're actually manipulating something, right? And then with quasi-experimental designs, Sometimes there's a variable that you're not able to manipulate, such as gender, SES, right? Like you can look at them as independent variables, but you can't assign somebody a gender for the purpose of your experiment. So things like that. This table, I would say that you don't need to know all of this. I mean, Nick, jump in if you remember differently, but I don't think you need to know as detailed as all this, but I would say to kind of know the different subtypes of the different designs. So even though this seems a little bit tedious, if I were you, I would actually go over just like the difference between these and the difference between these, and just kind of know some of them are pretty conceptual. There's a little bit of memorization on some of them. So I would just kind of go through that. A tip that I do like all the time is if I don't understand something or something seems confusing on this document even, right? Like just because this is 152 pages doesn't mean it's written in a way that everybody understands. YouTube is like my best friend when it comes to understanding stats concepts. Like if there's no Hawk video on it, or sometimes even the Hawk videos are kind of confusing to me, you know, and then it just takes a little bit of YouTubing, right? YouTube, Solomon 4 group, and you'll find an example that explains it in a way that will make sense to you if you spend a little bit of time on that. So those are always great. There's like so many people who just have like stats YouTube like sites, you know. So yeah, not much to kind of go over, but just kind of know that. Okay, validity and reliability is a big one. Does anybody want to give it a shot at first explaining what the difference between reliability and validity is before we go to the different types? Anyone want to give it a shot?
Reliability is like, validity is like if it's true or not true, if you're measuring like what you're intending to measure, and reliability is like repeatability kind of.
Yep. Yeah, there we go. So reliability, if we were to do the same thing over and over and over again, would we get the same result? Validity is what we're measuring, actually what we intend to measure. Know the difference between those two. Could you have one without the other? Like, could you have reliability without validity, and could you have reliability without validity and or validity without reliability?
Yeah, you can.
Which one? You could have one of them. You can't have the other one.
You can have reliability without validity,
Uh-huh.
but you can't have validity without reliability.
Mm-hmm. Why is that?
Because you could be measuring the same thing over and over and over again, but it could just be something you don't care about or you don't even know you're measuring, or something that wasn't intended.
Yeah, exactly. So like a good example for me is if I have a scale, like a scale to weigh a person, right? And my scale is 5 pounds off. It's 5 pounds off. It's broken. The little meter thing is off, right? I could reliably get an incorrect weight, right? I could stand on the scale, and every single time I stand on the scale, right? One day, the next day, the next day, the next day, it's giving me the same number, right? So there's a reliability aspect to that, right? I'm repeating it and the same thing is coming out. But is that number an accurate representation of my weight? No, the scale is broken, right? So you could like consistently get something that's not actually measuring what you want to measure. But the reverse is not true, right? Because if you think about it conceptually again, like if we want to make sure that we're measuring what we intend to measure, right? If we're getting unreliable results, meaning one day we're getting one weight and the next day we're getting a different weight and the next day we're getting a different weight, we're not accurately measuring what we want to measure because we're not getting the same thing, so we can't. Does that make sense? It can't be valid if we're not getting the same thing consistently. So remember that. I feel like that's kind of a tricky-ish distinction that is just a good like research design area to have hammered down, like know the difference between the two, know how they're related to each other. There's another thing about reliability and validity, which is that reliability sets the limit to validity. So what that means is like if you have a reliability coefficient, so let's backtrack. Reliability coefficients go from 0 to 1. So 0 is like not reliable at all. 1 is like perfect reliability, right? If you have a reliability coefficient that's, let's say, 0.6, right? 0.6 is your reliability coefficient. Then your validity coefficient cannot be higher than 0.6. Am I saying that right, Nick? Pretty sure that's how it goes. So reliability sets the limit to validity, right?
I'm not going to trust my brain on that one.
Okay, I'm pretty sure. I was actually reviewing it yesterday in preparation for this, and that was the example that I saw about the 0.6. So if it's a little bit confusing to you guys, maybe like do a little bit of research, YouTube it, like just kind of get a better grasp on that. But that's another thing. So not only could you have one, right? They say that reliability is necessary but not sufficient for validity. Like that's kind of the phrase that they use in general. So that's like one thing to keep in mind, but then there's a separate thing, which is that reliability sets the limit to validity. So validity always needs to be lower than reliability.
So Rachel, I have a question.
Mm-hmm.
So if like, let's say you have a, you want to do a scale and your scale is like super valid. Like let's say you want to measure PTSD and this thing measures PTSD.
Mm-hmm.
But so if it's like at 80% for validity and like, even though like it's a good valid scale, you can't use it because it's not reliable. Like, I guess that makes sense because it's not consistent. Okay, never mind. I answered my own question.
If it's not reliable, it's not valid. Like if that measure, right? Because if that measure really measures PTSD and it really measures what it's intending to measure, you need to get the same response. Like you need to get the same thing consistently. If you're not getting the same thing consistently, it's not really measuring PTSD. So you need to have that reliability component. So that is something to kind of know and refresh and study a little bit. And then there are subtypes of validity and reliability. Like there's subcomponents, right? So for, and you probably learned some of this in Foundations of Measurement, or you should have at least. So for validity, we have internal validity and external validity. Does anyone want to give it a shot? I know it's pulled up on the screen, but I'll move it away. Or I'll leave it up. Does anyone want to explain internal versus external validity?
I mean, the biggest thing for me is just remembering that external, it's just like almost like externalized to the population. So it says generalizability right there, but I just think how it can be externalized to the general public, kind of.
Perfect. Yep. And what about internal validity?
Isn't it based on like the population that it's being tested on? And that's why it's internal, because it's to them. And there's no other like factors playing a role, and that's why external, that's why like it is generalizable.
The second part of what you said is really good. Yeah, like that it's specifically what you're manipulating that's having the effect, as opposed to something else, right? The extent to which the intervention or manipulation of the IV can be considered to account for the results, changes, or group difference rather than extraneous influences. So ruling out alternative explanations. Make sense? But you're right, it's Venus, it's specifically within your sample. So internal validity is you're looking at, is the thing that I'm manipulating truly the thing that's making the difference that I see in my sample? And then external validity, could that be generalizable to other populations? Okay, so kind of note that. And I would just like scroll through this whole document. Like you don't have to read every single word of 152 pages, but just kind of look at the bold things. like you should know this, you should know like what is a null hypothesis, what is an alternative hypothesis. You probably all do already, but just kind of have those words in your mind because that's what research design is, right? It's like designing research studies. So you need to know things like reliability, things like validity, things like the different kinds of hypotheses and all that. Okay, know this, type 1 and type 2 error. That's a good research design area as well. Is anybody confused on type 1 and type 2 error? Took me a while to get it, to be honest. Anyone need a refresher?
So not on type 1 and type 2 error, I think that, like, concept of it makes sense, but like, you know how sometimes they'll put a graph of where the type 1 and type 2 error is confused with the graph?
You're breaking up a little bit.
Am I breaking
I
up?
think he's asking about the
Okay, so can you hear me now?
Yeah, keep going. I like kind of heard you, but you broke up.
Okay, can you hear me now?
Maybe you want to type it in the chat?
Well, anyway. Yeah. I'm at my house now, so I'll be able to ask it in a second.
Okay, sounds good. We could keep going, and then when he pops back on, we could go back. So type 1, type 2 error. This
I think he
explains.
was asking about the graph that shows the difference between type 1 and type 2 errors.
Like this?
Yeah, the one with the distributions though, where you can see the shaded parts being type 1 error and type 2 error.
Oh, like that, the table that I've showed some of you guys with like the overlapping humps? Okay. Yeah, that's a good graphic. Let me see if I can find that. I should have it. This one, right? Yeah.
Yeah, that's one.
Okay. So we could come back to that when he pops back on. Okay, know the difference between independent variable, dependent variable, control variable, the different types of data, right? The things that you learned. I think you probably covered this like on Dr. Dallenberg's first class. Categorical versus continuous. Independent variables manipulated, dependent variables observed, control variables and covariates are held constant. Okay, this I just starred because just review it. Like, I don't remember learning these things in statistics. So this would be an area where maybe just kind of read it and make sure you understand it. It's multiple choice, by the way. So there's a lot of like the conceptual part at least. So there's some like recognition as opposed to like forced recall. So you don't have to sit there like memorizing every single one of these, but you should know that counterbalancing is when you change the order of things, right? Things like that, like just kind of be familiar with what these terms are. So I would go through these. So this is like page 15, matching, blocking, counterbalancing, double blind, control groups, I don't know who put these little finger pointing things in, not me, but somebody thought this was really important, so maybe know this, which you probably should because this is the sampling distribution, which is really important. So this should be standard, hold on, Theoretical frequency. I would think that standard deviation and variance would be here. I don't know. Somebody thought this was super important, so maybe just read this and make sure you kind of understand that. Sampling error. Different kinds of sampling. Convenience versus snowball versus stratified. So again, like, you don't need to make flashcards and be able to recall, like, what are the different ways of sampling, you know, but kind of be familiar with what is convenient sampling. Finding people that are convenient, right? Snowball sampling, stratified random sampling. If any of these feel like really confusing that you kind of want me to like explain or pull up a YouTube video or something, just like interrupt me and let me know. We have that. Oh, here we go. Okay, so this is what I was saying before, that validity requires reliability, but the reverse is not true. Okay, what are the threats to validity? There's a bunch of different threats, so things that could get in the way of having validity in your study. The difference between internal again, and then threats to internal. Did you learn this in Foundations of Measurement, like all the different kinds of validity, like construct validity? Yeah, so all that. What is construct validity? What is face validity, right? Like how is that there? How is that not there? Threats. Some of this is like, I think this whole document is kind of like a compilation of things. And so there's some repeats, you know, like external validity and internal validity are explained and explicated on multiple times.
Rachel, I think Ryan's waiting to get in.
Oh. I think I have to stop sharing.
Hello.
Hello. Sorry about that.
Sorry about that. Sorry about I was cutting out earlier. My question that I was trying to ask though was about like, you know how when you're doing type 1 and type 2 error and you have to do like, sometimes they'll make you draw graphs. So I was just wondering if that was going to be the case, like where you have a graph and it's showing you where the type 1 or type 2 error is, and like, do you have to know it on a graph or just do you have to know it conceptually?
I would imagine conceptually. Like I don't think you have to know any, I don't know. I've never, don't hold me accountable. I have not seen the comp and I don't remember exactly, but I think this whole graph is what you're talking about. And I think that it's just used to help people understand conceptually where type 1 and type 2 error fall and how they relate to each other. So I don't think you'll be told to like shade in portions of a graph or anything like that. But more so just understanding the relationship between the two and how it's kind of always like a push-pull, right? And where they fall. So the only thing with this graph is just, it's like a visual representation of the null hypothesis and the alternative hypothesis. And then the type 2 is here and type 1 is here. It's probably hard to see in a little box, but I mean, do you want me to go over the chart?
I don't know if that would help anybody else, then like I would like appreciate it. But if not, then I mean, it's okay. Like I understand too, like how it's related to specificity and sensitivity after covering like RLC curves and stuff. Mm-hmm. It's just like the graph itself for some reason that always really confuses me. Like I know the concept better than I do like know how to like, I don't know if that means I don't even know how to interpret. I feel like I know how to interpret it. It's just like that part always confuses me.
Yeah, I think if you feel like you know how to interpret it, like not visually, but just understand it, then I think you'll be fine. But all this is showing is that, so let's try to get it in the screen. So this hump is the null hypothesis. The null hypothesis means there's no real difference. This one is the alternative hypothesis that there is a real difference, right? So those are the two humps. Type 1 error is saying there's a difference when there is no difference, right? So you're part of the null hump, right? Because there's not really a difference, but you're falling in the alternative hump. So you're saying there is a difference. And then type 2 is backwards. It's not like as far as I understand it, and I'm not like an expert in any way, but I don't think this is like a statistical representation. Like I don't think SPSS would make this, like would generate this. You know what I mean? I think it's just a visual way of kind of explaining it. You think that's right, Nick?
Yeah, and the only thing I would add is that if you want to start like calculating the power and stuff like that, which I don't think you're going to need to do for the comp, but a good reminder anyway, there's a free online software called G-Power that will let you know what the N you need with a certain effect size and how much power you would need to then detect that. So if there is going to be a tricky question, remember that power and these things are going to be related to the effect size and your sample size. And that's the things that are going to change how far apart they are or close, or how tall those peaks are going to be able to get, so you get that actually statistically significant difference.
And with that being said, does someone want to remind us what power is? What is power? So power is just your ability to see a real difference if a real difference exists. That's it. Think of it like a magnifying glass or something. It's like if there is a real difference, like the probability that you'll see it, that's your power. Power is 1 minus type 2 error, because type 2 error is missing something that's there, right? So if you have something, you have the truth, you have a true difference, like 1 minus your ability to find that difference, right? Or 1 minus the probability that you'll miss that difference is the probability that you'll see that difference. So that's why 1 minus type 2 error is power. Make sense? Okay. How are we all feeling?
Rachel, sorry, I have another question really
Yeah.
quick. Doesn't power also have to do with the magnitude of the effect size?
I think it's the bigger your effect size. It does have to do with it. I'm trying to remember exactly what it is. There are things that increase your power and things that decrease your power. Is that what Nick just said? That effect size increases power? Nick, do you remember? Are you back, Nick?
Yeah.
Remember that little like fraction that we learned about? That's not actually a fraction, but it's like the things on the top increase power and the things on the bottom decrease power. So like having a bigger sample size increases your power. Was effect size there too?
Yes. Well, and that's why I said that. Because if you have a really large effect size, you don't need as big of an N to be able to actually detect it.
Okay.
That's why when we go after things meta-analytically, we can detect things that are statistically significant at an effect size of 0.1. It's there, but this is where we get into the difference of clinical significance. Are you really going to accept a 0.1 effect size in your treatment, or are you going to want to do the thing that's a 50% or 0.5 correlation or something like that that's may actually, or a 0.5 effect size that may actually give you a significant difference?
Yeah. So effect size, sample size, increased power. And what decreases it? I mean, obviously a smaller effect size and a smaller sample size, but there was something else I remember.
Large amount of variability. So if your standard deviation is super big, you're going to need a massive N to be able to overcome that. Even if it is a larger effect size, even if the effect size is large, but there's so much variability that overall the distributions are overlapping each other, it's going to be hard to detect things.
Yeah. Does that make sense? A lot of it is kind of conceptual. Like if you think about, if you know what each of those things are and you really understand them, then it's easy to kind of, like it makes sense, right? If there's a bigger difference, that would help you see a difference if it exists, right? So like just kind of knowing that conceptually. Okay, let me share screen again. Someone else in the waiting room? No. Okay. Different kinds of designs, just kind of know what they are. This one, I don't know, it's like sticking out of my mind for some reason. So maybe review like just this whole section. I found a really nice YouTube video. I can send it to you guys explaining Solomon 4 group because I was like, what is this? So I can send that to you guys because sometimes you just need an example and then you're not memorizing these random things. You can just think of it in a story, you know, and then it kind of makes more sense. So go through those. And again, when I say go through those, like don't make yourself crazy. Like again, there's the whole comp, right? You have the SPSS part, the conceptual part, and then the conceptual part is split kind of between the things that you were learning all year and then these. So it's not like the whole exam is going to be on this. And I would say that you probably know more than you think you know about all of these concepts just by reading research papers, doing your decision trees where you're like thinking about independent variables, dependent variables, study designs, right? So you probably know a lot more than you think you do. Ceiling effect and floor effect. Does anyone know what that is? Anyone want to give it a shot?
Floor effects are like when the scores are more concentrated on the lower, so it like, I forgot the effect. I guess it says right there, reduce the amount of variance, and then the ceiling effect is the opposite, so it's just all the scores are more to the top. So the example that I saw was like, think of a test, and the ceiling effect is if it was a super easy test and everyone was concentrated on the top, and then floor effect was like if it was a really hard one, everything scored towards the bottom.
Perfect. Perfect example too. Yeah. Okay, this is probably what you learned most in Dr. Sweeten's class, right? Like a lot of these things. So just kind of review some of that. Again, nothing too crazy. You don't have to like memorize the specific number of these, but kind of be familiar that when you see something like this, what does it mean, right? Okay, know this. So mean, median, mode, what those are. Range, standard deviation, variance, know what they are conceptually. Maybe like how they're related to each other, right? How are they related to each other? Or what's the difference between variance and standard deviation?
Standard deviation is the square root of the variance.
Yep. Standard deviation is also like in the same units as like what you're measuring, but then variance is in different units. Things like that. Know the normal curve. Know the 60, where is it? 68, 95. Should have it somewhere. You know what I'm talking about? 68, 95, 99.7 curve. What does that mean? Confidence intervals. This stuff is a little tricky. You might want to review this a little bit. Like the relationship between the mean, median, and mode. Meaning, like, let's try to find an example to explain it. basically like what's bigger than what changes based on your skew. So if a test is very difficult and almost everyone in the class did poorly on it, right, it's going to look like this because there's going to be much more people bunched around the lower end, right? If this was like a, whatever, 50 to 100 on the bottom. And that changes here. In the case of a positively skewed distribution, the mode is smaller than the median, which is smaller than the mean. So maybe just go over that. Could be a little confusing, but again, if you kind of understand it conceptually or like think about it through an example, it might make sense. But I would say to review this a little bit. So this is page 39. Just like when the distribution changes, how does the order, right? Like what's bigger than what kind of change? We have kind of repeat of the different kinds of data. What is a z-score, right? How does a z-score kind of relate to a normal distribution? If I tell you that somebody has a z-score of 1, right? Then like, would you know sort of where that falls on a normal distribution, right? And the answer to that is just, so when you have a normal distribution and you have your mean and your standard deviation, the z-score units is just a mean of 0 and a standard deviation of 1. So if somebody has a z-score of 1, that means they're 1 standard deviation above the mean. And then whatever the mean is and whatever the standard deviation is, you just add 1 standard deviation numerically to the mean, and that's the person's score. So kind of be familiar with that. Tons of YouTube videos on that if that doesn't make sense or if that's confusing or yeah. Let's see if there's anything else. Okay, and then this document goes through all the assumptions. So if you're kind of confused on what the assumptions are, I started this just because like you need to know this more for the SPSS portion of the test, but this is a nice kind of description of what some of these assumptions are and what to do if they're violated and what statistics kind of check for them. So that might be a good thing to kind of look at. Don't need to know something like that. Let's see if I start anything else in here. Like a lot of this stuff is more like the conceptual stuff from the year of stats, right? Like some of these things, like part and partial and semi-partial, the difference between mediation and moderation, right? Like things like that might be on it. And that's what I mean by like conceptual questions about your year of stats as opposed to the research design stuff.
Rachel, can I ask a question? Oh,
yeah.
Sorry.
No, go for it.
Like when you guys took this, did it feel more like a Dr. Dallenberg exam or a Dr. Gebert's exam, or did it feel like, did it feel like Richard Gardner wrote the exam and it was like all the stuff that is based off of Hawk?
I think they all write it together. I think Dr. Gebert's and Dr. Dallenberg write it together.
Off of that question, though, all of the SPSS stuff, you're running yourself and you're writing a result section. So you're not going to be locked into answers. And we'll go over when running stuff a little later, kind of what things you should be pulling and double checking. So from that perspective, from the statistics, you shouldn't be as locked in to a tricky response.
Sounds good. I mean, I remember it being tricky on some of them, and not so tricky on other ones. I remember there being stuff on research design that I was like, ooh, we didn't learn this, We'll probably learn this next year. But having reviewed this document, right, it was helpful. What's this? Oh, this was moderation mediation, understanding the difference conceptually. tolerance, right? These are all kind of like free game for like conceptual questions of things that you learned this year, which again is why I think it's so beneficial to at least attempt to take the comp right after you take this class, because those things leave your mind if you don't keep refreshing them. Sensitivity, specificity, know that. Here's another pretty graph about type 1, type 2 error that also takes into account specificity and sensitivity. So this is a nice pretty one, page 81. Power. Oh, here we go. This is actually exactly what I was thinking about, this fraction thing. So sample size and effect size increase your power. Within group variance decreases your power. But this is not a mathematical, like it's not like you multiply your sample size by your effect size and divide it. That's not that. Just a way of depicting which things increase and which things decrease. Scales of measurement, just the different kinds of data again, nominal, ordinal. Like I said, there's a lot of repeats on this document. Oh, here we go. Here's the 6895 thing. So a nice description of that. Page 86. We need a refresher. Back to reliability again, all the different types. Are y'all kind of getting a feel of like, right, like reliability, validity, types of research designs, things like that? Here we go. Validity will always be lower because reliability sets the limits. This is what it's called, maximum validity coefficient. If unreliable, validity must be low. There's definitely like multiple ways of asking questions about that are pretty standard. Here's the different kinds of validity that you guys learned in Foundations of Measurement. Face, content, criterion, construct, things like that. And then there's like just a lot of summary tables with definitions and stuff. And again, don't make yourself bananas. You know what I mean? Like you do not need to know every word on this thing. But I do remember it being very useful to have like read through this at least. And like, even if I didn't read every word, like read all the headings and just familiarize with myself with like, what is a Solomon 4 design? Like, you know, instead of seeing, I don't remember if that was on it or not, but things like that, right? Like just kind of having seen them before. So I think if you guys like go through this, I think that's pretty much it. These are all just like tons of summary tables. Here's sample questions too. Sample test. So there were more samples. So
sorry, can we go through some of the sample questions and kind of like talk through them? I think that'd be more helpful for me than like guiding me to like what part of the study guide I need to like focus on. Okay. So, I mean, if other people think something else would be more helpful, I just wanted to request something.
Yeah, we can try that. The only thing is it's 1:58 and the second half is going to be Nick doing SPSS stuff to kind of remind you how to do all the SPSS stuff, but we could do like a few if that works.
I went through the all the answers are like after there's like 3 or 4 sample tests, and it really helped me like get a feel for how the multiple choice is going to be, and it breaks it up. So if anyone like needs to do something before Friday, that like really helped me.
And did it give you did it give you explanations for why the right answer was the right answer on those?
It didn't give me explanations. It just gives you the letter the letter of like which one was correct. But I just looked on YouTube. If I didn't like know something, I would like star it and then just go on YouTube or look through the like document before, like Control F the right answer, and then kind of just go through that.
Okay. Yeah, that's a great idea. So there's like a few. Huh?
Sorry. Quick question. So with that, with some of the practice problems, there were like decision tree type questions. Should we just brush up on that since obviously we can't have it on the exam?
I don't think there's decision tree as part of the comp.
Oh, okay. There were like some questions like, oh, you're given a study with this type of data and this type of data, what would you run? There's like one question that asks about point by serial and stuff like that.
I don't remember having to know. Do you remember needing to know that? I remember needing to know that for the final, but I don't remember that being on the comp. Do you know?
Okay, so if you're just talking about correlations like you just said, yes, you need to know that because you have a different correlation depending on what kind of data you have. Pearson is two continuous variables. A Spearmint is two ordinal variables, if I remember correctly. I never fully memorized these myself, so yeah. But so that becomes really important because your interpretation actually changes. Now, is it going to be a full question like what is this study probably using? No, it's not going to be a full decision tree on the exam, but there may be a multiple choice question about what specific test is being used, whether it's correlation or what kind of t-test would that be, because there are 3 important kinds of t-tests we're going to need to know.
I would imagine, this is just my best guess, but I would imagine that if you will be asked questions on that, it will be of designs that you've learned throughout the year, like between versus within group Anova, right? Like at this point in your stats career, you should know kind of what design, right? Or like what research question would lead you to choose that test without your decision tree in front of you. I highly doubt you're going to be asked like where the decision tree response is like some random test. You know, sometimes you go through it, you're like, I don't even know what that is, but that's just the box that it led me to. I don't think you'll be asked that, you know, because you don't have your decision tree in front of you. So I think if you are familiar with everything that you learned this year in your preparation for the comp, then you should sort of know that, you know. I feel bad that we didn't go through sample questions. We don't really have time. But I will say that just kind of looking at this, I'm even just looking at the responses. Like, do you see how they're kind of just like terms that we were skimming through? Covariate, IV, DV, confound, covariate, right? The different types of groups, counterbalancing, floor effect, ceiling effect. We don't really have time to like speak out why that's the right answer for all of these, but if you feel like you want a little bit more one-on-one help tutoring for this, email me. And perhaps we could make that work some other time this week. But hopefully that gave you more of like an overall sort of bigger picture, what to focus on. Again, everything that I went through is probably like a quarter of the comp, you know, or maybe even less than a quarter. So don't make yourself crazy studying 152 pages. Just kind of know the general ideas, especially the things I pointed out, like types of designs, reliability, validity, more of like the central ideas. I think that's all I got. Anyone have questions on any of that stuff? Of course, no problem. Caitlin, I saw you unmuted, but no sound came out.
I said thank you for going through.
Oh, no problem. And yeah, like I said, if you want some more kind of one-on-one help or like smaller groups, and you want to spend an hour or something going through some sample questions and fleshing out why the right answer is the right answer. I don't have tons of time this week, but I can probably make something work. So just email me. All right. And now I will turn it over to Nick to do the SPSS part.
Hi, everyone. I'm sure you're used to the sound of my voice at this point after an entire year of being your TA. So before we get started, I am going to go through some of the basic ones that we never really learned, but was kind of expected to know and was on the decision tree. So none of this today is technically going to be new, but it is going to be ones we maybe haven't explicitly gone over in class. Now, before we get started, though, because I want to make sure everybody has this one pretty down pat, is what are the different t-tests and when would you use what t-test when?
Independent samples t-test.
And you would use that one when?
Is that the one when you you're comparing it to a mean that you know of?
So that's independent samples t-test are 2 samples, and you're trying to tell if those 2 samples are different.
Okay.
The one that Kat was saying was one sample t-test, right? That's like one group to a norm, like a normative data set or something, it said.
Exactly. And so again, if you're thinking about which one do I need to run, if it's they're double checking correlation there and there's a known, or double checking is it different there and it's a known population that you're comparing a sample to. And remember, terminology could get you there. Are you comparing a population to a sample? There's your one sample t-test. Are you comparing two different samples against each other? There's your independent samples. Are those samples independent? And then there's your paired t-test. It is one sample at two different time periods. Now, given that, let's jump straight into the fun and handy dandy SPSS. And sorry, my computer's very much lagging. I think it's dying on me. So we'll see how this goes. We can go right here to compare means, and we have one sample t-test, independent samples t-test, and your paired samples t-test right there. So if we go to one sample t-test, of course, we have our test variable, and you have a test value of, is it different than whatever mean it may necessarily be? And then you have that 95% confidence interval. So then it's basically going to say, based on the standard deviation, is it different than that value?
Wait, Nick, so what do you put in the test value? That would be the mean of the normative group?
Yes.
Okay.
So if we do that, is it different than 4? That's a t-score of 1.648, degree of freedom of 9 with significance of 0.134. Now, the way I phrase that right now for everybody, I did for a very explicit reason. That is how I would frame what data you need to pull right now. So I would, and I know there's no words written on the screen, and since Rachel is recording this, you guys can come back to this too. The data that I would pull out of here is on whichever sample this is, there is not a significant difference between mission 1 and a reference value of 4, parentheses t, or parentheses t, parentheses 9, and parentheses equals 1.648. So there's we're dealing with a t-value, our degree of freedom is 9, and that value is 1.648, comma, p is equal to 0.134. So that is all the important things that need to be known for this test. The t-value is 1.648, the degree of freedom in there, and then there's that critical p-value. Anybody have any questions on that?
Do you need to calculate the effect size too?
It's not significant, so why do we care?
Oh, I meant like if it were significant, sorry.
We could, you don't always necessarily get the effect size. When you're just trying to say differences of mean like this in the t-test, you don't always do effect size. Effect size in Anova and regression and some of those other ones can be a little bit more, but.
In the practice, it asked for the effect size, which we had to calculate by doing like the t-value squared over the t-value plus the sample size. You can't get it through SPSS. You have to calculate it by hand.
Well, then I haven't done that. If that's in there, I don't remember us doing that in the comp last year.
Okay. It was in the comp SPSS practice.
Okay. Well, if it's in there, then learn it. Right. I guess generally know it. I didn't use that last year. I don't know what's on the exam, so they might pull that out. I don't remember having us calculate an effect size like that. They're pretty much solely t-test and like maybe a quick hand calculation for Fmax, because Fmax is one that you should know if you violated Levine's, right?
I can share my screen if people want the formula.
Let's do that to be safe. Thank you.
Yep. Hold on, let me pull it up.
Also, while you're pulling that up, Ryan, I am jealous of the workout setup behind you.
I'm not even at my house. This is my brother's house. That's where I was. I went to go get lunch, and then I drove back, and I don't even have like my notes. I'm using my sister's computer, so I'm just like all out of sorts right now. But they do have a sweet gym.
I'm jealous.
So here is the one sample t-test, and then to get the eta squared, you have to do the t value squared over t squared plus n.
Kat, I
Okay.
saw that too on the sample thing, and I like had to scour how to hand calculate that.
Yeah, I found it on Hawk.
I don't think you need to hand calculate that though. I mean, on SPSS, you can just click the button to.
It's not on SPSS. So like I was thinking the same thing, and I watched the Hawk video, and this is the question it was asking, and it has it, the effect size is here. Yeah, right here. And I was like scouring how they got 0.16, and there's nothing you can click on SPSS to get the t-test to give you the effect size.
Oh, really?
And same thing here. Right here, 0.27.
And I doubt you'll be asked to do that. Like, I don't think you're going to have to do hand calculations of effect sizes, you know? I don't.
That's good to know.
Yeah, again, I'd echo that of just, we didn't have to do that. Again, I'm showing you guys t-tests right now because they do ask, are they significantly different? And then just double check what their means are and standard deviations are and have those down. But I don't think you need to calculate effect size.
Nick, really quickly, do you need to know how to, so it's more of the interpretation part of it. We won't have to run one of these since we didn't have to run them during the year, right? We'll just have to. Okay.
You're running these on exam day.
You're running t-tests on the exams?
You are running every test on SPSS this Friday. That's why I'm going through this right now. And that's why I'm going back through these that we didn't really do over the year, so that way you guys haven't even these down. And I will go over Anova again as my next big one because I know we haven't done that in 5 months. And then I'll touch regression, logistic regression, and stuff like that again, just to make sure that we've gone through those. So there is a method to the madness. So the next one is independent samples t-test. I'm sure nobody can see this, but I've noticed this over time. There's actually TAB right there on that little tiny square to where that if your eyes are good enough, you can technically actually see that it's two different groups of AB. And for paired samples, it's TA1, A2. It's super small and super specific, but if you totally space, there is a little way for you to remember which each one is. Okay, so for here, we can have two different ones in, and you could have a grouping variable to see if like maybe on mission 1 would be different by gender. I'm just going to see if mission 1's different than mission 2. Or actually I should just do grouping variable. We'll just do mission 1, gender is grouping variable. I think.
So Nick, when you're doing this, do you run each separately? So like it'd be mission 1, you put in the grouping variable and then label it 1 and 2 is for male and female? Like what you just did in there?
Yes.
And then
now I'm just double checking the numbers. This is actually an Anova sample I'm just using to show you t-tests. Normally, if it's going to be a t-test, there's just going to be group A and group B to contrast against, and that's it.
Then would you have to name the group like you just did?
Depends on how it's set up, because thank you, computer. And then you can technically change your confidence interval, but always keep it at 95. Again, that leaves your alpha value at 0.05. And then, yeah, it does it. So for this, you're going to have to define what your groups are. And for a independent samples t-test, you can't have more than 2 groups. And I'm going to say that one more time. You can't have more than 2 groups. The moment you have more than 2 groups, you are now at an Anova. So in terms of process of elimination of what you want to do, if you have more than 2 groups, go to an Anova. If you have 2 groups, You can use the independent samples t-test, or you can use an Anova. At that point, it kind of doesn't really matter. Interpretation doesn't really change. Are they significantly different or not? I'll just leave that there. Bootstrap just brings up stuff you don't necessarily care about, so just don't. And then we've already defined the groups. So now here, it gives us the mean and standard deviation. So again, if you're trying to list out if things are significantly different or not, I would say males that went on mission 1, comma, or parentheses, mean M equals 4.5, SD equals 1.29, were not statistically significantly different than females. M equals 4.64, SD equals 1.01. You can go into the Levine statistic here, but regardless, then again, we go T parentheses 8 for that degrees of freedom equals negative 1.91. P equals 0.853. Again, I'm just highlighting the numbers I know you guys are going to need to just have that sentence, and I'm trying to phrase it that way as well. Did everything I say here make sense?
Yes. So is that little blurb like, oh, listing out that like that's all we're gonna need to write for the APA write-up for the samples for all the t-tests?
Depends on what the question is, but yes. So if it was, were males and females different on mission 1, that would be my exact answer. So on mission 1, males were not significant. Males, parentheses, that mean and standard deviation, were not significantly different than females. Parentheses, the female mean and standard deviation, and then another parentheses with all the t-test data and all of that.
Hey, Nick.
Yeah.
Let me just share my screen super quick again, because I got permission from that girl. So let me just show you. Here. So here's a PowerPoint with like steps to do stuff, and then like an example of a write-up. So I'll send you guys this, but this is kind of what you would write. Something like this. I don't know if it has to be this exact, like every single word, but know that like, see this last bit over here, like that is the APA way to write results, right? Where you have like the statistic, the T or the F with it in parentheses with the degrees of freedom, then what the score is, p-value, effect size, right? Like know how to do that. And yeah, so there's in here, we have chi-square, t-test, Const, Anova with post-hoc, different kinds of Anovas, and Cova with write-ups. Does anyone know how to drag and drop or like how to send this to you guys in Zoom? Like it's not letting me drag and drop. Is there another way to do it?
Yeah, you can attach a file.
How would I do that?
In the 3 dots, it says attach file.
Mine doesn't. It just says save chat. Okay.
Put it on.
So
I'll just email you guys.
So to Ashley's question real quick of do we need to specifically write the p-value or can we write less than 0.015? Specifically write the p-value unless it's only gives you less than 0.001 because then it's so small, it's super highly significant. Be on the safe side, specifically write the p-value. It's not that much more. Spss just gives it to you. It's not like you're guesstimating ballpark numbers. So play on the safe side. Just literally write out what that is giving you.
If it gives you p equals, this is just in general to know, p equals 0.000, never write p equals 0.000 because that means it's like completely zero, but it could be p 0.0000002, right? So then you just do p less than 0.001. Even if you get a 000, you don't write a 000.
Exactly.
I have a question really quick on, so for this one, on mission 1, we assumed equal variance. Can you assume equal variance in a t-test even though you haven't, like, even though you didn't check technically for variance? Or is that, I'm forgetting.
This is our check. This is our Levine's.
Oh, okay.
So let's say you wanted to include that. Let's say you wanted to conclude that too, with equal variance is assumed, and then you could write F equals 0.26, or Levine's F equals 0.262, significance 0.623. Therefore, you've covered that your variances are equal. Therefore, you can assume equal variances versus not assuming them, because just the not assumption changes the degrees of freedom a little bit, which makes it a little bit harder to have a significant T because you can't assume that equal variance. Okay, so now if we do paired, now if we do paired samples t-test, it shows this interesting box where if we just do mission 1 as there, and we do mission 2 as the second variable, hey look, it's one variable with a time slot 1 and time slot 2 of mission 1 and mission 2. Same exact thing, can just hit OK. It gives us the mean and standard deviation, correlation, and then here's our t-test. Again, we care about that t-test, and that t-test is significant for once. So across mission 1 to 2, across mission 1 to mission 2, with mission 1 being 4.57, standard deviation there, mission 2, same thing. They were statistically significantly different, and then you could say T parentheses 9 equals to 0.810, P is equal to 0.02. Bam, there we go. So now, one other thing about data cleanup, because I know we didn't necessarily do it, we have talked a lot about how to transform, or when to transform variables and when that can be important. Now let's get into actually doing it. So we can go to transform and compute. And so we can create a new target variable. So let's do mission 1 trans. So just mission 1 transformed, and we can literally put mission 1 in there, and you can just take math. We can do a log transformation. We can do a log base 10, or a log base E because math, log base 10. You can do square root transformation, whatever you want to do. And so I could put in square root right, or, oh, come on, computer. So we can do square root of mission 1, and then this is going to go through, and for every single value of mission 1, I now have a transformed mission 1.
For that, Nick, would they ask us like on the question, like, oh, transform one of the variables or something, and then it would be set up like that? Or is there something to indicate that we have to transform a variable?
What are your indicators for needing to transform a variable?
Isn't it if one of the assumptions are broken?
Yes, and what assumptions are they?
Oh, I can't remember.
Normality.
Mm-hmm. And what two things that we can think about go into normality? Or I guess 3 things. There are 2 big ones and one I'm throwing in there just to make sure we all get it.
Skewness and
kurtosis and the curve.
Skewness and kurtosis. We call good skewness and kurtosis the normal curve. The one I'm thinking of is outliers, because that can then do things with your data. So skewness and kurtosis are the ones under the assumption, but outliers mess with those 2 things anyway. So I'm throwing it in there to make sure you guys remember to look at for those outliers as well. As a logic for when to throw out an outlier. And I'm just going to say this to make sure it's there because I don't know if everybody remembers this. Remember that when we only have like 10 people right here, if something's like an outlier at the point, oh God, what would that be, like a 2.5 level, you might already consider throwing it out with only 10 people, because 2.5 standard deviations up is only like 98%. You are above 98% of the other possible data in that data set then. So especially if you're getting to 2.9 or 3 standard deviations at only 10 people right here, I would be getting that one out. Now, if you have 50 to 100, I wouldn't touch that at all. In fact, that's now largely expected. But now if you have something at 4 standard deviations out, okay, now that's when you're thinking about with 50 to 100. Realistically, I would not expect a data set bigger than for any regression or ANOVA or anything, I would not expect a data set larger than 50 to 100. If he's doing factor analysis like we've gone over this last semester, again, that would just be exploratory because we cannot run confirmatory or structural equation modeling because we do not have AMOS, so take comfort in that. If you are running an exploratory factor analysis, yes, that'll have a couple hundred because that's when that really gets statistical significance and everything. Otherwise, just expect 50 to 100 and check all your normalities. Easiest way without needing to do a test, another statistical test, is go descriptives, put in all of your data. Well, you can do descriptives or the other one. Options, you can get your skewness, kurtosis, range, everything that you want. Descriptives is a nice and easy way. If you want one that can be a little bit more involved at times, you can use frequencies. The nice thing about frequencies is you can also make a ton of charts for these variables at the same time. So if you want to visually check as well, this could be a nice one to do it. Since these are all continuous, we could do histogram. Statistics, again, mean, median, mode. Skewness, kurtosis, min, max, standard error, like whole 9 yards. We can get absolutely everything. So if you're first coming in, you just want to see what the data is there without sorting through 100 people, just do this. Go straight to frequencies, run this, see what is there. You can already see here for skewness and kurtosis if anything seems funky or anything like that. Remember with skewness and kurtosis and SPSS, the critical value you want is the skewness divided by its standard error. The kurtosis divided by its standard error. Do not just take the skewness value. You want that value divided by the standard error of that value. That's the critical value that you're trying to look for.
What are this is a stupid question, but what are the ranges that it's supposed to be in to be considered normal again once you divide them? I always get them confused.
2 and 5, right?
So it's 2 for skewness, 2 and -2. And then for kurtosis, it's 4 or 5, like -4 and 5, like that, those numbers.
Go by what they're saying. Because they're online and with other stuff, there's technically other cutoffs. Since those values right there directly from Dr. D and Dr. G, go by those values. So Ryan, can you say them one more time just to make sure everybody has them down?
Yeah, so skewness is 2 and kurtosis is 4 or 5.
Okay.
Also, Nick, I have a question really quick about, because I know you just ran frequencies. Would you recommend doing frequencies like this on all the questions that they're going to ask, so you already have like the mean, like all this stuff, so you can check normality?
If you are able to keep it straight in your own head with needing to scroll through a long output, then yes, I 100% would.
Okay.
If you struggle to already interpret an output, I would try to keep it to just the drop downs of the one time you try to run it. Don't try to reinvent the wheel, but if it's helpful for you to already know what's going on like this before you run it once, then yes. Otherwise, you pick your battles. If you struggle to run things even once or twice, don't try to run 15 different things trying to iterate unless you really have to because you had to transform a variable. So I will leave that up to personal preference, but yes, Ryan, you can.
So,
or would I recommend it? Yes.
Sorry for all the questions, but So say we get to this data set and it's sampled here or whatever, and then we have to transform a variable because normality was broken. Do we then run again the frequencies and the samples t-test and act as if, and using the transformed variable and then looking at that new report, that entire thing?
Yes. For a t-test, it's not that bad because we have this equal variance is not assumed thing that can correct for us, and you can just say it was a independent samples t-test where equal variances were not assumed because we violated Levine's, and talk about your Levine's and have the quick thing about your Levine's. You can say that and move on. For the Anova, that's harder. But again, as Richard Gardner says all the time, an Anova is robust. So as long as it's not so incredibly bad, you don't have good significance at all, who cares? When things that are more sensitive, starting to get into regression and some of those other things, yes, 100% you have to rerun it and see if it's better. Does that answer your question?
Yeah, thanks, man.
Yeah.
Nick,
Okay. Yeah.
sorry, one more thing. On the t-tests for the homogeneity of variance, like it doesn't give you, it doesn't spit out like a Levine. So like in the practice, it was like comparing the standard deviations to one another, saying like they don't look too far apart, but it wasn't like anything official. It was just like they seem like they're okay.
Well, we do that even when Levine's is violated. What's the first thing we do when we go to Levine's being violated?
You do the F max.
Exactly. And what is F max?
Something over something.
You're taking the variance of the biggest one over the variance of the smallest one and see if they're too different. Variance is standard deviation squared because standard deviation is the square root of the variance. So yes, 100%. That's exactly what you would do. Now you could visually do it right here, 1.29 to 1. Yeah, I square those. That's not going to give me too much of a difference. Now, if we were talking 1 to 10, okay, that's going to be a big problem. Now you have a variance of 100 to a variance of like 1.1. That's really, really, really bad. So it's all relative, kind of like that. Does that answer your question?
Yeah, kind of. I was just like, it was a little bit elusive on the practice, and I was like hoping for something more concrete, but
F max of 10.
Okay.
There's not really a big statistical test for that one. That's just the F max of comparing those variances across each other. And so I guess that's another big tip for the comp coming up. Write it down, say what the logic was, and keep going. So just as Kat said, if Levine's was violated, what do? Levine's was violated, here is the statistic, here's the F max text. Then we did not have an F max above 10, and you could literally put the variance value over the variance value if you wanted to just cover yourself. That portion is not really in APA write-ups where you have the variance over the variance. You can just say, but it did not violate F max, an F max critical value of 10. You could just say that and move on. But you would want to put the statistics for Levine's. And then as part of frequencies, we have our histograms down here, which I didn't even look at skewness, kurtosis. Skewness, nothing's going to be violated there. Kurtosis, nothing's violated there. Yeah. Again, just quick math, dividing one divided by the other, and then there we go. Now, getting to the one that I wanted to get into a little bit more. I have here is just practice so that way everybody remembers again for an Anova, a repeated measures Anova, where there are 5 levels, which I should probably, before getting here, I should probably actually show you the data just to make sure we all know what it looks like. So from variable view, there's gender, male, female, and then there's 5 levels of mission. And if anybody did this practice last semester, this is the data set in Hawk if you want to do this after at home. So there's 5 missions, and then there's 1 grouping variable of gender. Now remember, don't fall into this trick on the exam of time is a variable. And so time here, this is a 2 by 5 with our, why am I forgetting what it's called right now? A 2 by 5 two-way ANOVA with repeated measures. There we go, because my brain can work. So it's a 2 by 5 ANOVA with repeated measures, where that 5 variable is time with 5 different levels of 5 different missions. So in thinking about that, we can then go here, general linear model, repeated measures, because we know we have repeated measures. We know that we have 5 levels on mission. Now we have to define it. So now there's each of the 5 ones here. 1, 3, 4, 5. Bam. And then we have our gender. Model you don't really care about. If you want, for plots, gender, mission, and then remember you can do, so there's the gender by mission. We can just do gender, and then we can just do mission. So that way we're starting to get here. We do have an interaction variable now, which now that I'm realizing it, it might be easier to do only two separate lines of gender, and then have the horizontal be 5 different missions instead of 5 graphs, making us all very confused. So think about little things like that when you're trying to interpret for what's easiest for you to interpret on the exam. Do you want 5 different lines or not? That's going to affect where you put things. I don't think there's going to be a 3-way. I don't remember having a 3-way last year. 3-ways just take a lot of time to really kind of interpret, slow down, and understand. So there we go. We can include error bars if that helps you as well, but I'm just going to leave them out for now. Oh, there we go. Post-hoc tests, again, if we want to run those post-hocs, estimate a marginal means, especially if you want to start just recognizing where the means are. And this can be important if they're starting to ask you about how to get simple effects, which that is something we're also going to be able to do. But so again, display means here, and if you do this, you can have that Bonferroni where it's correcting for all the different ones. LSD is no correction. Just remember that. If you're evaluating at LSD, there is no post-hoc correction. If you're going to use that, you need to state we used LSD and therefore had no increased post-hoc alpha correction. And then if you want to necessarily save anything, of course, we have these values here. So we run it, have all the same ones that we have seen before and have come back to us, and Manovas and everything else like that. We have sphericity, which does anybody remember what sphericity is?
That's like the ranking, right? Like the school of fish, and everyone should be in the same relative order.
Yes, exactly that. So what is this telling us right here?
Doesn't this say that we violated sphericity because it's significant? Yeah.
Yeah.
So it's a problem.
So there's problems in our data set. For the comp, state it and move on. Let me say that one more time so that way you can just get through it. For the comp, state it and move on. If it's something as simple as a normality thing that you can transform, then do that transformation. If it's a larger systemic issue, like if we go back to Manova, thinking about those intercorrelations and the covariate table and everything, and it's not just normality, state the box is M, state you looked at the variance covariance matrix, and move on. So pick your battles. It'd be better to answer more and be able to get through it than trying to constantly correct some of these things that take a very long time, or it's systematic error, and that's unfortunate, and that's what your data gives you.
Nick, really quick, when you have repeated measures like this and you do sphericity, aren't you supposed to, like, so you can't do the sphericity as assumed box because it's violated. So don't, like, you're saying don't even report the greenhouse geyser, don't even try to do that stuff, just
No. So this is exactly what you have to do, is you have to select which one depending on how, I think greenhouse geyser, lower bound is,
I don't remember.
yeah, I know. I think lower bound is most restrictive. Greenhouse geyser is second, and Heinfeldt's,
Yeah, the HF is the most liberal, and the greenhouse geyser is the most conservative.
So just state which one you used and move on. Again, it's gut call based on what Kat you just said. If this one's the most severe, if you want to be, or not severe, conservative. If you want to be conservative, just state you use greenhouse geyser for conservative. State and move on. That's the thing. If you really forget which one to use, just be like, I use this and move on. Just state and get the correct data from that row. Even if the logic is wrong, you'll get points for getting the right numbers, right? Because there's multiple aspects to how they're going to grade this. Did you make the right decision? Were you looking at the right things? And were the numbers right that you were getting from the table? So there's multiple different things to be graded on here. Again, reading an Anova table, F-tests, the significance on them all. We don't really look at this again still. We pretty much still assume linear-ish relationships. I know that these other ones are here, but even in class last semester, we didn't go into the within subjects or to this. We didn't go as much into what kind of relationship that necessarily was. And then gender was not significant here. And then, of course, we have our pairwise comparisons down here, which is starting to look at the effects. One reason why I'm blowing through this, though, is because I want to make sure we get back to being able to say how we get a simple effect. Because I'm going to do that by doing the split file function. So here, males, females, we have our 5 missions where things unfortunately went down. And for that, even though gender was not significant, I would be curious to see if what is the simple effect of males and females at mission 5 right here. Okay. So in order to be able to try to get simple effects, one of the ways that you can do it is the split file function. So it's here under data, the same place where we could define variable properties. We now have split file. Now in split file, we can compare groups by gender now, or organize the output by gender. So now, if we were to run the exact same thing again, it's all set up. I don't even need to really do anything else. It's all here. We run the exact same analysis again. I changed nothing in there. It now gives me 2 of everything because it's split by male and female. For that right here, if we look at just the male portion, we actually still got a little bit of significance. Excuse me, my throat's a little dry today. But this top one up here is only looking at the males, and then you have this second one down here only looking at the female data, because it literally split the entire file by analyzing males first and then analyzing females. Does that make sense? Okay. Now, okay. Now, in terms of interpretation of this, Interpretation gets a little bit interesting because you have to be able to remember what specific one it's talking about. So for here for females, you notice how mission is still here, but mission by gender is basically nothing. That's because gender's kind of falling away, right? Because we're only looking at females here. So this is a significant difference across females, which across all of our multivariate tests, they're not significant. Here, all of our within subjects, not significant at all. So these estimates right here are the estimates of only females. Same things with looking at all of the different missions within missions. So that is specifically more telling you now what are these differences only on females, and are those significantly different from each other. So from here we can now say the simple effect of mission at, or my God, the simple effect of gender on missions. I'm forgetting the way that is phrased. I apologize. The simple effect of being female on missions is not significant, basically. And then here, the simple effect of being male on missions is significant, which we still violate sphericity and greenhouse geyser 0.012 if you're being most conservative. So that's how you could say that simple effect is significant. Okay. From here, are there any other specific tests that you want me to run over really quick? And I phrase that way because we can just run over a regression again if you would like to. We could do a logistic regression. There's a couple of little ones that we could do, but I wanted to get your guys' input. I went through okay, let's actually double check the t-test ones because again, we never really went over that over the last 2 semesters. Went back over Anova because it's been 6 months since we've done that. And so just quick tertiary. The interpretation, again, hasn't changed. We're still looking at significance values. With Anova, we're writing down that F statistic then, and just remember to pull the right degree of freedom because you're now needing to pull 2 degrees of freedom. The degrees of freedom of that group and the total degrees of freedom because you need both now.
Can I ask a question? I don't know if you're going to have an answer. Is there anything you can tell on like how they're going to administer this with us, like how it's going to go down? So the way that it happened with my cohort last year, at least when I took it, was that you log on, they have you in individual breakout rooms. Every person is in their own breakout room, and you have to download a software that is actively monitoring your computer. And that is because you are clicking away from the site because you have to be able to run SPSS. It can't just be like Moodle Watch where it's watching your ability on SPSS. It has to be able to observe you. So you'll log on. There will be somebody that's paid in the room with you also looking, as well as that other system looking. And you will write out your answers. I don't remember if you submit your data files. I don't remember that, unfortunately. But you take the however many question multiple choice first, and then you go into SPSS. And you'll most likely receive a couple different data sets, maybe like 3 or 4. If they give you like one fat data set or something, which I don't think they will, but if they do give you one data set that gives you a couple of different tests, if you want to help yourself out because you get confused, run one test, save that output, and then run your next test so you're not getting confused. And just, again, little things, because exam day gets stressful, so you can keep it straight in your head. Don't try to have one long output that you're scrolling for 5 minutes through because you don't remember which test was what. Save it, and then run your next variables that are important for that question.
So you'll be in your own breakout room, like Nick said, with like a tutor or a TA or Rich or somebody like that, and your screen will be shared for the whole exam. So they're going to, like, you'll have your screen shared, and so they'll be watching you run the analyses. So yeah, but it's like a private little brick error.
Okay, I have a quick question, Nick. So like, I always use my calculator when I'm doing skewness and kurtosis. Are they going to let me do that? Because like, I'm not going to like, you know, want to do that in my head. Like, or do you need to do it in your head? Which I guess I could do, but I just prefer not to.
Use a calculator on your computer.
Okay.
Everybody has, at least I think every computer has a calculator on it. Use that just to be safe, because then when somebody's observing your screen, because you are required to be sharing your screen the whole time, so that way the person observing you sees what you're doing, so you're not pulling up random stuff. They can just see that you're calculating something rather than looking down as if you could be looking at notes.
Okay.
So yes, you can calculate it. Just don't look off screen too much as if you're looking at notes.
I got you. I also had one more question. So like, we kind of went over already, like part of like the reporting, like degrees of freedom, significance, that kind of stuff. So kind of the vibe I'm getting right now is like, don't worry about it being like how you did it on the project, where it's like the specific correct way of doing it. Just report the stuff that's important, because that they're going to grade you on that, and don't worry about making it like APA, like good style, kind of good to go. Like you don't have to worry about that. Just try to get as many done as you can.
Write it well. We've all read research articles before. Write it well, make it consistent, state what groups there are that are different, and then right after the group name, have that mean and standard deviation as we would include with APA writing.
It should be in APA format. That's like part of the thing. I would say that I think what's most important is like the way that you're writing the results themselves, right? Like F, open parentheses, the degrees of freedom equals, comma, like that you should kind of have down pat. I would imagine you would get points taken off if you don't do that accurately. But like Nick was saying, like you're also kind of explaining what you did. And I think that part, it's a little looser. Like just make sure that you're explaining like what the difference is and what groups were compared to what groups and things like that. Like you'll see even the thing that I'll email you guys with the sample write-ups, like the non-numerical part, I think is like a little different in between them. You know what I mean? Like I don't think that's as formulated, but make sure you're writing the numbers in APA format.
So what I was thinking is like when you're doing a multiple regression, right? And there's like a bunch of different assumptions that you have to like talk about there. So specifically when you're talking about like I get the whole like, so P's, and then like when you're doing the T value and you're writing that stuff out, that needs to be set kind of squared away, good to go. But like, let's say you're talking about like, I don't know, another value that you would be like, let's say you had skewness on one of the predictors. So you're just like, there's no specific way to write that. You're just writing, okay, this one was negatively skewed at -2 point or -3 point, whatever, 566, and it doesn't matter. That's okay. Okay, got it.
Yeah, I think so. And I would say, sorry, I had to step away for a little bit while Nick was talking. So if you heard this already, then forget it. But in your write-up, you're also writing about your assumptions, right? You're writing like, and for independence of observation, right? Did you go over this already, Nick? For independence
Not today.
Okay, for independence of observation, like what's the catch with that one? There's no way of checking for it, right? So in every write-up that you do, you should write the assumption of independence of observation is assumed, right?
The only one that we can test that for is Durbin-Watson for regression, because that's the only one we can. Otherwise, Anova.
So make sure in each write-up that you're also showing, right, that you know what assumptions go to what analysis and that you checked for them, and either you did something or it was assumed or passed with flying colors, and it's fine. Something that really helped me, because I would say that the hardest thing for me the week before the comp was trying to memorize what assumptions go with what tests. Like that just felt like so much, and I couldn't remember all of that. And so I wrote, like made up funny sentences. So let's say like Anova starts with an A, and then I would write on a piece of paper like all the assumptions that go with Anova, and then I would make up like a funny sentence that starts with that, just like for each one, because it's actually a lot of memorization. And that's something that in every analysis, you're going to have to do that. So I would figure out some sort of mnemonic to help you remember all the assumptions that go to each one.
But on that note, yes, Ryan, just write it out. Just make sure you have it. So I guess I wasn't being as clear as I probably should have been. Yes, write out everything. Do it in the best that you can in APA format, but at the same time, you have to get out what assumptions did you test for. Did you correct for it? What was that correction that you did? So like, let's say you did have to transform one variable. I log transformed this variable and then the skewness value went within tolerable limits, and then move on. So it's kind of like do state and move on. Don't like sit there for 20 minutes being like, oh God, how do I state this? It'd be better to almost get the info down if it's not perfect, just to make sure you say, hey, I did the right thing. But you want it as close to APA as you can 100%. Like you want the degree of freedom. You want the T value being right. You don't want to make it a T when it's an F value because it's actually an Anova. Like try not to make those little things and be as accurate as you can.
Second question. Sometimes when you do tests and then there's like other like smaller analysis that you can do, like you run an Anova, but you could also run a T. You could like, you know what I mean? Like you go more specific. Do we need to do any of that for the comp as well? Or it's just running the basic kind of stuff? They're not expecting you to go like that kind of deep.
I would expect simple effects in your Anovas. I would expect at least one simple effect in an Anova. Whether you use a split file, whether you're able to use a t-test for those, I don't fully know. I would expect to need to run a simple effect.
And moderation, like how we learned how to center a variable and like for multiple regression and doing moderation, that kind of stuff. Should we brush up on that as well?
Well, that's already right there. Just like I went to the programming the variable right there and just did that quick little square root. You can do it right there. So you just basically take the standard deviation or the mean of that minus the variable minus its mean, and there you go. It's centered. So yeah, you can do that really easily if you need to go through that. I don't think mediation and moderation is going to be on this exam as much, only because that's kind of a lot, especially if you don't have that Sobel test thing also downloaded on SPSS. If you're worried about it, we didn't have to calculate Sobel test, did we?
I don't remember. I don't think so.
Yeah, because that's the thing that takes a long time to be able to do, and that takes a lot of extra stuff as well. They're most likely going to keep it within SPSS because it's easiest. You need to know the basics, and we know what moderation and mediation is, and if you're really going to do it here, you're probably going to work with Dr. D and Dr. G for your dissertation. In terms of the comp, all the basic stuff, Anova, multiple regression, even logistic regression, means understanding those odds ratios and things like that's going to be something from an interpretation standpoint they're going to want to know. So that is something I would, if I were you guys, I would go back for logistic regression to be able to do that. Maybe discriminant analysis as well, and just recognize that that's the linear relationship. Again, no CFA or structural equation modeling. You might need to do a path analysis, if anybody's remember what that one is, and that is just multiple regressions. Okay.
Is that software to do that?
No. So that's the difference. We cannot do structural equation modeling, which structural equation modeling also has latent variables. Ones that is a latent factor that we get an estimated score, you're right, probably based on other things, but path analysis can be done with multiple regressions. When we first learned connecting all the boxes together, we just had multiple regression. And then we got into structural equation modeling later when we got to EFA and CFA and added latent variables.
Really quick, Nick. So if we ran multiple regressions, what are we comparing with the path analysis, like the significance levels and the?
They will give that to you, and yes, is it significant or not?
What are they giving to us?
They will give to you most likely the path that you would then want to figure out.
So like they would give us the variables and then we just put the like significance levels and like, now I'm getting confused. If anyone, I don't know if anyone else is confused or I'm just not understanding this.
I'm just hoping that they don't put it on there.
Because like what I'm thinking is like they're giving us the paths, but what do you mean they're giving us the paths? Like, are we running the paths? Like, that's what I'm not understanding.
Yes, you are running the paths.
By using, like, we would run one multiple regression and then right after we finish that, we would run another and then we compare the results of both of them.
That's how I'm understanding it. Oh,
So they will give you the path. You have to decide what regressions to run to be able to recognize where the relationships between these variables are going.
And by how we would, sorry, Ryan.
Go ahead.
And how we would know the direction is how?
Is arrows most likely, which mine does not include enough of. So for here, you'd basically be able to see that we start at X, X goes on to Z and W, W goes to Z and Y, and Z just goes to Y. So you would need to calculate one multiple regression for X to W, another multiple, or I guess that would be a simple regression because it's just X to W, a multiple regression for X and W onto Z, then another multiple regression for Z and W onto Y. That is path analysis, and we can do that because those are all measured variables, hence the boxes. If it was the circular one, it's a latent variable. Then, as Kat said, that's structural equation modeling, and we are unable to do that unless we have SPSS AMOS.
And then, sorry, I'm being tedious. This is like, I don't really know what to do in this situation. So after we run the simple regression, if it's just one like path going to one or whatever, and then the multiple regressions, then we just compare, like we just report the significance levels and saying like, oh, this one is significant, like this path is significant because
with the regression coefficient and everything, yeah.
Why?
Mm-hmm. And remember, when you report that, you report the betas, not the Bs.
The standardized betas, right?
Yes. That's why I say betas, not Bs.
And then we use the unstandardized Bs as the, like for the equation?
If you were doing the equation, yes. When it comes to path analysis, you're not going to have one equation that maps onto Y. Here you're looking for where is that variance being transferred through. So from looking at this, X has no direct relationship with Y. X goes through Z and W, but W also has an effect on Z. That would be, I think that would be the most complicated one if they were going to give something like that to you, because that's just a whole bunch of multiple regressions that arguably multiple regressions, assuming no violations there are no violations of assumptions or anything like that. You could pump those out relatively quickly.
So, sorry, but say one wasn't significant, then we would just report it and move on. Like you said, like this path that was whatever was not found significant, and then
exactly.
Just look at that and move on to the next path.
Exactly. So. The path was not significant. That's it. And that's something I know is a little bit lost in class when you're trying to just find answers for the exam. If it's not significant, it's not significant. Your data is your data. Like, as much as it's been important for us to say, how do we interpret significant data, because that's a thing in and of itself. But if it's not significant, state it wasn't significant. Therefore, there was no difference, or there was no statistically significant relationship between these two variables. However it is, that is just as important, especially for the comp, because that interpretation goes both ways. Are there any other questions?
Do you have any like random tips to not want to die right before?
Keep cool. Try to not overcomplicate things in perspective of, if you see an ANCOVA, like let's say you're just surprised by an ANCOVA, get down what you have down, get down those assumptions. Remember, an ANCOVA only adds like 2 new assumptions. The other assumptions are a normal ANOVA. So I know like the way it's presented in the semester is like, oh my God, new test, what do I do? Let's take that step back right now. And I know that can be hard, but if you take that step back right now, just be like, oh wait, I've already learned 4 of them. There's only 2 new ones. And just try to think about, how do I test that assumption? And that's why a lot of my TA sessions I've been trying to say, okay, how is it all connected? When interpreting, thinking about decision tree stuff, well, what variables do you have? What kinds are they already in the first place? Just asking that question can give you so much information already, because you just got lost in the weeds real quick. Take that step back. What do you have? What do you need? Just ask those questions and keep going. And then once you have the test in front of you, read the table. If there is an extra box that Dr. Gevirtz clicked or that I clicked that confuse you when you don't need it, don't click the box.
I have one more question, kind of similar. Like on the practice exams, it says like run an ANOVA or run a t-test. And like this goes back to the decision tree. Are all the questions going to be like run this?
Probably. Closer to that. And if it doesn't give it to you, it's probably an easier give me question of just what's the difference between these 2 samples? And then that's going to go back to that independent samples t-test thing immediately. That's why I really wanted to give you guys those t-test ones, because those low-hanging fruit ones that are a little bit faster, but didn't really learn in class, I did not remember that going into my comp last year. I BS'd that very hard. So I wanted to give that to you guys, since I know I didn't really get that last year.
If they don't tell you straight up what to run, it'll be really obvious, because that's not right. It's not a conceptual part of the exam. Like they want to know that you could run it, not that you have to start trying to figure out what analysis to run. But it would be something super obvious, I would imagine, like what's the relationship between blah and blah, and you would need to know to like run a correlation, which you probably should brush up and just know how to do, like a simple correlation between 2 things, something like that. But even that I feel like it's not the point. Tips that I would say is like, I remember being kind of pressed for time. I felt kind of rushed when I was doing it, because it's a lot to do in a short amount of time, and I'm not like the fastest worker. I'm usually like one of the last people taking exams, and I felt like really pressed for time. And so I would kind of like get the basics down for each analysis and like make sure your general ideas are down and your data's in there without making it like the most beautiful language like Ryan, you were asking about and stuff. If you have time to make the language like super beautiful, go back. I remember feeling like if I had another half hour, I probably could have made it sound prettier, but it was better that I just like got through everything, and like the numbers were in APA format, and I explained what I was doing, and I mentioned each of the assumptions, right? So just kind of like hammer that out, like mention assumptions, say what you're doing, run it, report the results, and then move on. If you have time to make it pretty, go back. And I'll also just say, like, I say this a lot, but show off what you know. Show off what you know. Like, you all know so much more statistics than you did a year ago, like so much more, and by the time you're sitting at the exam, like there's nothing more you can study. Like you're sitting there, right? So like your only job is to show off. Show off, like do your best. And if you get a little stuck on one little nitty gritty thing, like don't do that part and do something else. You don't need to get 100 on the comp. Like, you just need to pass it. So just focus on like what you know and do the best you can. And worst case scenario, if you don't pass the comp, it's not the end of the world. Like, don't go in thinking like, oh my gosh, if I fail, like life is over and I'm a horrible student. Not true. Like, worst case scenario, you'll take it again in August. You spend a bit more time studying. Like, it's not the end of the world. I have a feeling you all will pass, but just in case you don't, like, don't be really hard on yourself.
And then two things. Let SPSS guide you to. SPSS is set up as a program meant to make statistics easier for social sciences. So like, use that to your advantage. And two, last thing to memorize, which is one thing I would just memorize for the simpler ones, is what correlation is what. So that way, what is the correlation between these things? Well, are they two ordinal? Is it a continuous and a dichotomous? Is it two dichotomous? What is it? And then which one to test when? If I remember correctly, I think the Pearson technically gets converted to point bar serial. That's the one he messed with you guys with on the multiple choice of that exam. I think it's Pearson to point bar serial of two continuous, or point bar serials then continuous to a dichotomous. And SPSS auto converts that as long as Pearson is clicked, which is why I'm bringing that up. And it was brought up on that exam, and I don't want you guys tripped up again. Spearman is different, and then I think tau is the last one that I don't really remember tau. But yeah, again, last thing for if they just say what's the correlation, double check what kind of variables they are, and then what correlation you need for that relationship between those variables. And that's it.
Last question, super quickly, sorry. Is there like amount of time like we have to take on the multiple choice, and then on the, or it's just kind of like we get the whole whatever X amount of hours and then just do it when we can type thing? Okay.
You have the 3 hours, multiple choices first, SPSS is later.
How many multiple
I don't remember.
Okay.
I think 40 to 50, something like that. So it's not astronomical, but it's a hefty sum to where that, for me, and again, this is me, I probably went a little bit faster than the multiple choice, especially because I didn't realize as much of the research methods things I probably should have remembered. And then I focused on SPSS because I knew how to run those pretty quickly. And as I know you guys have been able to tell over the course of the year, I'm a little bit fast on the SPSS sometimes. I need to be slowed down. So take your time where you need it, almost plan that ahead. If you recognize you're faster on SPSS, but you feel you need more time on the multiple choice, take those extra 20 minutes, go back through it, or the few that you flagged for yourself. If you need more time interpreting, running the SPSS output, it might be better. Get those multiple choice down, even if it's just 50-50 sometimes, and get to SPSS. So go in with a little bit of a game plan. Of course, you don't always know going in exactly how it's going to go for you that day, but think what's more valuable for you. Are you faster with SPSS? And it might be important to go back through, grab some of the practice data sets off Moodle that are still on there right now, run through them. Can you run them pretty quickly? Can you intuitively immediately know? Let SPSS guide you to say, this variable should go here, this should go here, this is the interpretation.
Yep.
Yes, writing can take you 5 to 10 minutes and take time, but can you pull that info off quickly in the first place?
Practice like just making it like habitual. You know what I mean? Like how to run an Anova. You go here, you go here, you go here, you go here. This is what it looks like. Like just practice that a few times on data sets, because even if you are fast, it's not like you have one analysis to do. Like you're going to be given like, I don't remember how many we had, maybe like 8 or something. Like it's like 6.
I think 6.
Like 6 analyses to run, to analyze, to write up in like an hour and a half or something is like, I felt really rushed and I was like there till the last minute. You know what I mean? So if you could kind of prepare in such a way that by the time you get there, you don't have to be like, oh shoot, like how do I run an Anova? Like which button do I press, you know, or like what assumptions go here, where it's just quick. And then you could spend your time like actually running it and writing it up.
And that's it.
I just have a really quick question. if we like to like take notes while we're taking an exam, should we just kind of like have a Word document that we're taking notes on instead of like should we not be like writing and looking up? Like, should we just have like for them to see that we're just kind of like thinking while we're like working?
I'm not going to say yes or no. That's a Richard Gardner email question, I would say. He is, even though he has all his minions to make sure to proctor each and every individual, he's the guy who's over going to see everything. So email him to be sure of what are the limitations of that. Can I have a Word document up on my screen taking notes that the person can see or not?
And if you're sending that email, Sophia, just throw in the question that I forget who had about the calculator. Just
right.
like that as well. This way you can share with the class like the notes and the calculator portion.
Yeah, definitely. I'll let you know.
Okay.
If anyone needs, I was taking notes during this entire thing. I know it's recorded, but if anyone needs it, just text me.
And I am here by email. Let me know if there's any last minute, like major questions. There's a concept or something just stumping you. I'm here too. I don't just disappear at the end of the year and cease to exist. So by all means, reach out.
And if y'all want more individual, like I said earlier, tutoring sessions, let me know. I probably won't be able to do like one-on-one, but maybe if there's like a few people, we can make a couple different groups happen. So just email me if you need, and I'll send you the this link to the recording along with that thing I shared from the girl with the sample write-ups.
Thank you so much, Nick and Rachel, for doing this.
Of course.
Of course, guys.
Thank you. Yeah, thank you.